Hi guys, my name is Emily and I'm a peer expert at the Psych 2220 Learning Lab, and today I'm going to help you with power. So you've made it through nearly half the semester and you understand hypotheses testing, you understand p-values, and you understand that you can increase power by increasing alpha, which also increases the amount of type 2 errors. You know to turn a two-tailed test into a one-tailed test, you know to make the sample size bigger, and you know to decrease the standard deviation, and you know to exaggerate the mean difference between levels of independent variables. But what does this all mean? Where does this put us? What exactly is power? And that's what I'm going to help you with today. So the true definition of power is the probability that we will correctly reject the null hypothesis. And another way of thinking of it is the probability that we will get a small p-value, which will lead us to rejecting the null hypothesis. Now, what does this look like in our data? Here on the whiteboard, we have population 1 in red and population 2. These are the different populations that we will be comparing during our hypotheses testing. And remember, our null hypothesis usually means that they are going to be the same, equal each other, or be similar in one direction or not if it is a one-tailed test. However, let's assume this is a two-tailed test, and here our null hypothesis is going to be that they are the same. So we have our two populations, and this is what the outcome of our data is. And now you see this small overlap of the tails in the middle, and this is highlighted in purple. Now, this overlap symbolizes power. So this means that we have our populations and we want to take another test. So we take a few sample data from population 1 and we randomly take a few pieces of data from population 2 and we run another test. The likelihood of that test showing that those mean values are in the same distribution is going to be low, meaning we are going to have a low p-value. And now with that low p-value, we are going to want to reject the null. And if we keep doing this, we are continuously going to get a small p-value. So this overlap shows that we have high power. We are going to most likely, rather than not, correctly reject the null hypothesis. Now, let's say that this situation is a little different. We have our first population, and now we have our second population, and these have a little bit more of an overlap. Well, that's okay, because now if I highlight in purple, this overlap is bigger, and this is going to show us that there might be less of a chance to correctly reject the null hypothesis because the distributions overlap more. And another way of thinking about this is that if the two populations share more of the distribution, then we are more likely to get a higher p-value, which would lead us to fail to reject the null, therefore giving us a less likely chance to correctly reject the null, leading to low power. And if this has not helped, then your book gives great examples of the different types of power and how each of the 5 ways to increase power affect the distribution. And this is on page 237 to 239. I hope this helped, guys.